construct and understand frequency tables for a set of data given class limits. So we're going to do some fun stuff today. So frequency, the number of times a value occurs, right? That's just a straight number. The frequency table is really just an organization piece, right? The frequency table, we are arranging values least to greatest with corresponding frequencies. So it's really just a way for us to organize things, right? So it kind of looks like this, where we have the values in the left and the frequency in the right. So maybe we just have three values, 1, 2, and 3. 1 appears 10 times, 2 appears 14 times, 3 appears 18 times, right? It's a way to organize and arrange our values least to greatest with corresponding frequencies. That's it. But what if our data is all spread out, right? Like these, we have nice 1, 2, 3, we could list them. But if I have data all over the place, really spread out, I can't list them all. So then what do? Well, let's check it out. So we are going to do a problem, and with this, we're going to walk through all of the steps. So create a frequency table using 6 classes to include all of the data below. So you see we have some numbers here, and they range from 7 to 69. With everything in between. Well, not everything, but a lot of things in between. If I had to list these all out, it would look really crazy. So we are going to do this example of going from here. So you might want to hit pause, write down these numbers, and then follow along step by step. Here we go. Step 1. When you are creating or being asked to create, sometimes you're told how many classes, but sometimes you're not. So your first step is always to determine the number of classes for your frequency table. You want this to be between 5 and 20. Now, I'm a big fan of between like 5 and 10, but depending on how many numbers you're dealing with and how wide the range is, that's where you might get up closer to 20. Okay, so we know we are going to have 6 classes. That was told to us in the problem. So we are ready for step 2. Calculate the class width. Now, the class width is found by taking the maximum number minus the minimum number and dividing by the number of classes. Now, if you end up with an integer, when you solid number there, you always want to round up to the next highest whole number, because if you don't, you're not going to have enough classes. Okay, so we need the max and the min. So if we go back, the maximum is 69, the minimum is 7, and we're using 6 classes. So max minus min divided by the number of classes. So I have 69 minus 7 over 6. So 62 over 6 gives me 10.3. Now, we always round up to the next integer. So my class width is 11. Sometimes you might do a class width with decimals, but generally we keep them whole numbers. So we round and our class width is 11. Great. So now we know this. 6 classes, class width of 11. Let's move on to step 3. We're going to create a table. 1 row per class, 3 columns. Okay, so we think through this. We're creating a table. We have 3 columns, 1, 2, 3. We have the lower class limit, the upper class limit, and the frequency. Okay, now we know we're going to have 6 classes. So 1, 2, 3, 4, 5, 6. Right? So these are the 6 classes that we have. But you need 3 columns, lower class limit, upper class limit, and the frequency. These first 2 are going to kind of show you the interval that you're dealing with. All right, step 4. The lower class limit for the first row is the minimum value in the data set. So when I say, okay, to start, right, my very first row, the lower class limit is my minimum value. So I start with 7 because 7 was the minimum value in my data set. Okay, so that's how we get started. Then we say, okay, so we have our first lower class limit. So we take the lower class limit of the first row, which is 7, and we add the class width, which we know is 11. We found that in step 2. So now if I take 7 plus 11, I get 18, and that is the lower class limit of my second row. We continue to find the other lower class limits. So then I would take 18 plus 11, and I would get 29. And then I would take 29 plus 11, and we get 40. And then we get 40 plus 11, and I get 51. And then 51 plus 11, and we get 62. So that is how we find our lower class limits. We just keep adding our class width. Step 6. The upper class limits are simply one less than the next lower class limit. So if we go from 7 to 18 with the lower class limits, well, 18 minus 1 is 17. So that's how I find the upper class limit. It's one less than the next lower class limit. So 29 minus 1 is 28. 40 minus 1 is 39. And you should see between the upper class limits, we also have a difference of 11, which is the class width. So then I have 50, I have 61, and 72. So for that last one, you have to recognize your pattern of add 11 to get your 72. Now I have all of my lower class limits and I have my upper class limits. So now I'm ready to calculate the frequency. So our numbers were given to us in order least to greatest. They're not always in order, but this is how I generally go through things. I say, okay, 7 goes in here, 9. So I like to say, I usually make marks, especially if they're all over the place, because then you can tally them up that way. Because these are already in order least to greatest, we can just count. Between 7 and 17, I have 1, 2, 3, 4, 5, 6 numbers. Between 18 and 28, I have 1, 2, 3, 4. Between 29 and 39, 1, 2. Between 40 and 50, 1, 2, 3. Between 51 and 61, 1, 2. And between 62 and 72, 1, 2. Now, it is always good practice to add up your total frequencies, right? How many of these do I have? So 6 plus 4 is 10, 12, 15, 17. I have 19 numbers. Are there 19 numbers in my data set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yes, because you want to make sure you don't miss any. And that is how we calculate a frequency table with classes, intervals, with a big span of values.